Don't forget to like and subscribe. It's Jim Keller, everybody.
And welcome to a Tech Poutine. It has been a while. Both George and I have been incredibly busy. I've been eating this ice lolly because it has been 25 degrees Celsius in London today.
And unlike me, you don't have AC to keep you nice and cool.
Well, I mean, I do. I bought one last year.
Oh,
but
okay.
The fact that it's April 8th is...
I mean, just I think like 2 days ago, it hit 100 already. And I'm like, it's too early in the year to be hitting 100.
I mean, you're a lot further south than I am.
Yeah, but usually it doesn't hit 100 till at least late May, early June.
It's when I was in town for GTC and I went down to LA for OFC, it hit triple digits. It's, yeah, being able, normally we say April showers, so being able to walk around in shorts and have sweat dripping off you just doing a 35-40 minute walk. But that's by the by. Like as George said, it's been a few weeks since we had a poutine. Part of that is I spent pretty much 6 weeks constant on the road, including 2 weeks vacation, plus some family stuff happening. George, likewise. George is. You went to a few events I didn't.
Yeah. So I went to the ARM event that we're going to be talking about later. Yeah,
it's being so long. It's been what, 2 months since the last poutine. Let's be honest. We don't have a regular schedule because of all the travel and what have you. So there's a lot of things to talk about. So we've kind of picked and chosen what we have been most interested in, or what we think has the most impact, and a bunch of stuff that has been at least on the radar. I mean, I'm still taking consultancy calls. And people are still asking me the same things.
So just before we get started, if most of you have probably been watching this with me, but 7 days ago was the launch of Artemis II, which is the first time that we've done a flyby of the moon with human flyby of the moon, and some of the pictures out of Artemis II have been amazing. My phone screensaver, my lock screen, is the now famous Earthsat photo.
Is that not the Apple login photo?
No. So that's probably one of the Apple lock screens was Earthrise,
right?
Which was the Apollo 8 image. This is the counterpart. This is Earthsat.
So two things that come out from those photos. One, people want the raw data, raw files, and they get annoyed when people tell them you have to wait until they land because they're too big to submit over whatever limited data stream they have. And two, Getty Images has already taken them, and now you can buy them with a license. The thing is, how do you license a public domain image?
And they're all up on the NASA website, mind you.
You don't pay for a license. You pay for the delivery. So the new Earth marble image.
Yes.
$375. Or free.
Insane.
The thing is, what I bet it is people who have Getty Images subscriptions. It's included in that because, of course, it is. It's a public domain image, really.
Scarro says the XF metadata is crazy. 50,000 ISO. Yeah, it's pretty crazy when you consider what they're having to do to take such a quality image.
The amount of photographers bitching online about the cameras that they took with them as in, why is it, a Nikon D9 or whatever it's called? And it's like, well, because that's the one that's been verified to work in space radiation environments.
I will say, I think it would have been really cool if they had managed to get one of the Apollo Hasselblads from back when Apollo flew, and they had redone the image with that camera. But other than that, like, that's sort of more nostalgia and just
the funny
like
thing,
cool.
The funny thing is, people are saying, "Oh, but they also took iPhones," right?
Yeah.
So it's as far as I know, the next one.
So Artemis 3 is going to be an unmanned landing on the moon with the lander for Artemis 4. And Artemis 4 will be the 21st century's Apollo 11, essentially.
So I think it's Artemis 3 is going to have a number of higher quality, more modern sensor type cameras. Like, for example, I think somebody complained there's no 360 camera in Artemis 2?
So there is a 360 camera, but as far as I'm aware, NASA has not opened that up publicly.
Oh. Is this like an Insta 360 type crap?
Yeah. They're using a 360 camera for like monitoring of the capsule, stuff like that.
No. I mean it's the like $80 Instagram 360.
Oh, probably something like that, yeah. But $5,000 because it's space hardened, right?
Oh yeah. Oh, and if you take into account the cost of the fuel to get it into space, it's actually 10 grand.
Yeah.
Because what is it? Is it 10 grand per pound to get something in space?
No, SLS I believe is something in the region of.
Or it's got a lot cheaper with SpaceX, but when you put it on a manned mission, it obviously changes the economics.
I think technically SLS is like
what's
$3.5,
SLS?
$4 grand a pound or a kilogram.
SLS, sublight speed?
No, space launch system, the rocket. Because that price varies by rocket. Right?
Yeah.
Because I think SpaceX is like $250 a kilogram, or even less than that now, which is insane to think about.
Yeah. It turns out Musk did something right. Or the people who worked for him did something right.
Yeah. That really more that than anything.
I know, but the money's got to come from somewhere.
True.
And it's the one business that doesn't leverage debt like the others do.
Well,
but didn't SpaceX just IPO?
Yes.
To a 1 point something billion? No.
I don't know. I don't know what I did not pay attention to the IPO.
It filed for an IPO. So it filed the S1, just like Cerebras filed for the IPO. Targeting a $1.75 trillion evaluation. Most valuable companies.
That's Nvidia, Google, Apple, Microsoft.
By market cap, yeah. I'll just give me a list. Yeah. It would put it as the sixth highest company by market cap as of 2025 Q4. It would put it above TSMC. It would put it above Facebook, Meta, above Broadcom. I don't know. There's some argument that some of these companies' valuation is inflated because of AI.
Hold on. So unfortunately, the main competitor to SpaceX is UAL, or United Launch Alliance, and that's
the UA-Link Consortium.
Yep, Yeah, but it's a joint venture between Lockheed Martin and Boeing.
Yeah.
And if you combine the two market caps of those companies, who do far more than just rockets, that's about 310 billion in market cap.
That's only 310 billion. Yeah.
Mm-hmm.
So 1.75 would be hype. But SpaceX does have how many government contracts? Like all of them?
I mean, how many does Boeing and Lockheed Martin have?
Yeah.
So
enough for your rivets to fall out mid-flight.
Zamodius says in chat, SLS is $4 billion per launch. Cheap in comparison to Apollo. Actually, if you look at the cost of Apollo in today's dollars, was more per launch.
Hey,
like in the end.
But what is the
I call it cheap.
What is the value of giving the middle finger to Russia?
Yeah, that's basically what we did.
Rather than an open hand and a brothel.
But yeah, no, I'm very excited. So yeah.
It's funny. There's this clip of this kid who was, physically viewing the launch, and they said, "Why are you so interested in a launch?" And he said, "Because we're going back to the frickin' moon, man." But most news organizations bleeped fricking. So it sounded like he said fucking.
That's funny.
And this kid's like 7.
That's double funny.
And in another science news that's not part of the typical Poutine, Large Hadron Collider is shutting down for 4 years.
Oh, HLC shut. Oh, why? Maintenance?
They are upgrading a 1.2 kilometer stretch to be able to detect anywhere from 50 to 100 times higher energies. So it is a upgrade on par with the installation of the ring itself. It's using very much the latest technology in order to do that. So yeah, so we're not going to hear anything out of LHC for 4 years. Last time it shut down, it was a bit. It's like, oh, you have to shut down, but to upgrade, and they've done amazing things since the upgrade. So it's just the next stage. So somebody should tell Orange Cheeto that having massive rings that fire protons gets you a Nobel Peace Prize.
That's yeah. Well, let's not go there right now.
Okay, chat. Let's get this show on the road. With something like an official intro. So hi everybody, and welcome to the Tech Poutine, the weekly-ish or once every couple of months podcast where we usually talk about processors and silicon and how we've taught very special rocks to think in very special ways. We're called the Tech Poutine because my name is Ian and I run a channel called Tech Potato, and my co-host is George from Chips and Cheese. If we had a guest, they would be the gravy, thus making a lovely Tech Poutine. Also, we have a sponsor. It's us again. Actually talking to some companies about sponsoring the Poutine, so it'll be really good if we can get those on. So if you do wish to sponsor the show, do let us know. We do accept and read super chats made by our listeners and watchers, but only if they don't demonetize the channel. You know who you are. The show usually lasts a good couple of hours, sometimes more, but stick around and hopefully we'll get to some Q&A as well. But today's first question is to George. How you doing?
Doing okay. Been busy. Expecting.
Hey, this is the busiest time in semiconductors ever.
Yeah. And speaking of busy time, I got a little present from our friends at Dell. Got a Panther Lake laptop.
Sorry, but you showed that off, and that just definitely looks like it says 6.
There we go.
No. You just showed a laptop that says 6. the light.
Does it?
The light hitting it.
I pulled a Musk, didn't I? Oops.
Yes, you did. So George has a what? So you've got a Panther Lake Sex laptop, basically.
Yes.
Is that the Ultra X9?
It's the X7358H, which the only effective difference between that and the top end SKU is 300 megahertz on the P core.
Okay. And yeah, that's a, how many cores is that?
16. It's 4 plus 8 plus 4. So 4 P cores, 8 E cores, and 4 LPE cores.
And no simultaneous multi-threading.
No.
In this generation.
No,
but XE12.
Yes. Yeah, it's the B390 GPU.
So yeah, it's the big bad boy graphics. And have you tested the power yet?
No, I literally opened it, so I got it, opened it, made sure that it was powered on, went, got lunch, came here.
Okay.
So that was the span of events.
So in the land of show and tell, because we're clearly not starting this episode properly.
No.
If anybody follows me on social media, you may have seen me post this.
Oh, I know what that is.
It's not obvious from what this is, just by showing it that way. Let me read what it says on the CPU. AMD Opteron ARM Cortex A57.
That is AMD Seattle.
The one-off AMD using ARM as the main CPU core chip designed for enterprise, announced in 2014. Technically came out in 2016.
So
the chip has a tape out date of 2014. So,
but fun fact: a lot of the bring up for Linux was for AR64 was done on that board because that was the first commercially available 64-bit ARM CPU.
No, you say that. If you wanted to buy one, everywhere it was sold said launching soon, and then they went to out of stock. Not even pre-order available, and that's because it was an enterprise SKU. So the OEMs and the ODMs and got them first. So the thing is, it was also advertised as one of these embedded chips with a 10-year operating system image longevity. So, so they keep the drivers up to date for 10 years. So it worked. That has just expired. So that made, what I think has happened is that some distributor in the UK, because I got this from eBay, found a few in their warehouse. I tried buying some from China recently, and none of those sales would go through. For anybody wondering, this is called the LeMaker Cello 3. I believe the seller on eBay has something like 4 left. It's about £70. And it takes a DC 19-volt in, PS2 keyboard, 2 SATA ports, PCIe slot. The chip is meant to have 2 10-gig Ethernet ports. So the chip itself went up to 8 cores, but this is the 4-core version. And DDR3L or DDR4 up to 1866. And one of the memory slots is on the back. I don't think I'll ever get around to firing it up. It does come with a heatsink. I just took it off because I wanted to take a picture.
So it's a adornment for the wall.
Yes, and an excuse to post rare stuff on Twitter. As much as people hate, like or dislike Twitter, one of my goals this year is to get monetized, just so I can take at least a little bit of money off of the Elon.
Yeah.
Though in order to do that, I need 5 million impressions in 3 months, and my record is 4.4, I think.
Mm.
And it just depends when I tweet a lot, and or rage bait. Though posting rare silicon usually gets me some of the way there. I also have, and it's actually in another room right now, so I can't show it to you, the world's lightest laptop. Japan only special from Fujitsu.
Oh, of course it's Fujitsu. Okay, yeah.
It's Windows.
I should have guessed.
It's an Intel Ultra 7 15-watt SKU with 32 gigs of memory.
Let me try and guess the weight. Has to be less than a kilogram. Has to be less than 800 grams. I'm gonna say somewhere between 600 and 700 grams.
There's a new feature now in our back end that means we can play music. I want to find the Jeopardy theme tune. Dun, 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 dun.
782. So I was off. I was off by a little.
No. It is 628.
628?
1.3 pounds. You pick it up and it feels like it's one of those empty fake ones you get in IKEA. But no, the battery life is genuine. For anyone wondering, it's called the Fujitsu FX-U3. Is it the FX-U3? No, it's something else. UX-K3, sorry. So IPS panel, 14-inch device, a 2230 SSD. Yeah, $1,800. And
they somehow managed to put full-sized, or almost full-sized arrow keys.
Yes. The only downside is it's an anglicized Japanese keyboard.
Oh.
Which is fine. The OS is a single language version of Windows. And so you have to go through the setup all in Japanese, which is a pain for if you don't speak Japanese. And then once you do get into Windows, you can change the language to English. But unfortunately, all the control panel is still all in Japanese. It does have RJ45. It does have a HDMI port, a full-sized one. It does have Type C. It does have a Type A. And it charges via Type C, and it has a 3.5mm. It's not fanless.
No, I wouldn't imagine it would be that thin of a form factor, or sorry, that light of a form factor. Excuse me.
Because it turns out if you want a bigger heatsink, that costs weight.
Yeah.
It's I believe it's some form of magnesium carbon fiber mix. So, but yeah, no, it's a modern. I'm going to make content on it. I'm going to do videos on it once I get the current array of content I'm busy doing out. So,
but it's only a 31-watt-hour battery.
So they claim 7 to 17 hours of usable work time. We'll see. So yes, you might think, well, don't that mean you have to carry around a 700-gram 99-watt-hour rechargeable backpack anyway? And I'm like, the answer is probably yes, but I do that anyway.
Yeah.
So, yeah, we'll see. So let's just mosey into our first topic, because this is one that George was at the event. I covered remotely. And there are different ways to approach this, but ARM announced their first merchant silicon data center CPU. designed and built in-house for as much as that's worth, which means that they are now offering a processor like their own customers are. And
So
this has been a rumor for a while in general, and the argument always is why would ARM make a chip that technically competes against their own customers?
So I'm sending you a couple PDFs, but because this is going to become important. But
yeah, I've got them.
Okay. So yeah, so ARM announced this CPU, and to dive into the specs, to dive into the...
Well, tell people what happened first.
So I went to the event, and in most events, what happens is you go to the event, you fly in, and basically that first fly-in night, you basically just have dinner. And then the next day, you go and you have all your pre-briefings, you get to ask your questions, and then the day following that is the keynote or the announcement. Yeah. And then the day after, you go home. Cool. That's not what happened here. What happened here is I flew out the day before the event, and we basically just, like I said, we just basically had drinks and like refreshments, basically. And then day of, I wasn't pre-briefed. I wasn't anything. So I was on the ground.
To be honest, I don't think anybody was.
No, there were people that were pre-briefed.
Press or analysts?
Both. Our friend Tobias and Timothy Pratt Morgan were pre-briefed on this.
Okay.
Along with some analysts, such as Fudo, was briefed.
Mm-hmm.
So I know that there were people pre-briefed. I was not. So I went into the event not even knowing technically what the event was about. I had been hearing rumors about what this was going to be about, but I had nothing from ARM saying that this is what it was going to be about. And I actually didn't get any slides until 15 minutes after the keynote had ended. And it was the slides that were available on the Media Kit site.
We have to say our good friend Sally from EU Times is in the chat. She says yes, Tobias from the Register was pre-briefed. EU Times was not.
Yeah, no, the Register was pre-briefed. I wasn't. Sally wasn't. So some people were pre-briefed, some were not. It was kind of strange. And then if you look on the slides from what ARM was showing, they did not go into the detail that Sally...
Explain what they were showing.
So they were showing off their brand new, and I do not like the name, their ARM AGI CPU. That is the name of the product. This is a 136 core, or up to 136 core CPU using Neoverse V3 CPU cores. So this is ARM's latest server core that also goes into AWS's Graviton 5 and Microsoft's Cobalt 200. So same core in theory. However, we'll talk about that a little bit in a second. And this has 128 megabytes of what they call SLC, but it's L3, and 2 megs of L2 per core. Okay, fine. Specs look decent for what this product is for. And then we get to the memory side, which is 12 channels of DDR5 up to 8800 and 96 PCIe 6.0 lanes with, and I did get this clarified because the spec sheet is a bit confusing here. It is CXL 3.0 with type 1, 2, and 3 support. So that means that memory devices, I/O devices, and cache coherent devices will all work with the AGI CPU. Great, cool, awesome. However, for some of these, for some of these details, that's not even the actual slide deck that you want. You want the one from Mohammed, not this one, if you want any detail on the.
Yeah,
here we go.
This is kind of
the one slide.
Yeah.
This is the one technical detail slide that we got. And if you look at this compared to Intel or AMD or even ARM's own slides for their IP, this is pretty lacking in terms of information, right? You get the up to gigahertz number, you get the memory latency number, and that's really about it. Now,
so George, just play devil's advocate here.
Mm-hmm.
What if I said this would be sufficient for a keynote if more detailed information was provided subsequent at the event?
Yeah,
would it be sufficient for the keynote?
If there was more to this, like if there was a whole nother slide deck that talked about, like, how did they do, how is the mesh configured, how was the SVE configured? We'll talk about that in a second.
What's the die-to-die connection?
What's the die-to-die connection? What node are you actually on? Is it N3E, N3B, N3P? Ends up it's N3B. But these questions were not answered, right? So I really had to go and sort of hound them on questions about this. So
we'll get to that in a second. I want to highlight this, that was my key takeaway.
Mm-hmm.
So yes, okay. So you've now got a CPU that's like this, and you have over many memory channels. And part of the discussion right now is how much CPU performance do you need in your agentic AI workflow, right? For the longest time, when we're dealing with an AI server, we're talking about 2 CPUs to 8 GPUs. And then something like NVL72 uses 1 CPU to 2 GPUs. AMD Helios uses 1 CPU to 4 GPUs.
Mm-hmm.
Meta, on their NVL72s, uses 1 CPU to 1 GPU. And I'm even seeing talk of some people saying, well, maybe you need 2 CPUs per GPU. You need 1 CPU for I/O, 1 CPU for orchestration, and then you have your GPU. And one of the things that's come out of all of this last 2 years, for those who follow it, is that people rarely talk in terms of chips or servers
Mm-hmm.
anymore. They're talking in terms of systems, and usually in systems that means racks.
Mm-hmm.
And so obviously NVL72 is the one everybody knows from Nvidia, and Helios is the one from AMD. And every startup under the sun will have some quarter rack, half rack, full rack solution, what have you. ARM, I think, has turned around and said, well, hang on, what about a CPU only rack? If we're going to move into an agentic workflow that needs a lot of CPUs, why don't you just have a bank of CPUs on your network? So they're saying here that in a standard 42U rack, are using OCP v3 standard, 36 kilowatts, you can have 8,160 CPU cores. Now, I should note that if you do the math, that actually means 600 watts per CPU. So they've intentionally halved the amount of cores for the power. And I think that's just to take into account what might be network control, DRAM, other additional minor accelerators like hardware, HSEMs, that sort of thing. and switches in the rack. But then if you now go to double wide racks, the open rack wide, which is like where the Helios is going to be, you can have almost 46,000 CPU cores in a rack. Now, I'm not saying they're wrong. My question is, who has asked for this?
That is also a question that I didn't get a particularly satisfying answer to, or an answer that I was particularly satisfied with.
I mean, it's all very well saying our customers.
That's what I got as a response. It's like,
yeah, but that's the weakest answer you could possibly give, because no shit, it's your customers. But at least give us some context. Are these customers, what vertical are these customers in? What are the example workloads they're using? You can abstract that away, so you don't need to tell us the company. It's or you know, perhaps the argument could be, well, GPUs no longer do 64-bit, so you need CPUs now. Hey, that might actually be that might be an answer. I'm not saying it's a particularly good one, but it might be an answer. But yeah, unfortunately, this slide felt to me more you could do this because rack scale is a thing. Yeah. Not you can do this because you need it.
Yeah.
So.
Oh boy. Okay, this slide. So this slide, in conjunction with what Mohammed said on stage, something about not having to support Lotus notes, or not. Something along those lines.
His argument basically being, if you start with a new design, you don't need to support the 30 years that come before it.
The issue is that a week after this presentation, IBM and Arm announced a collaboration that will be bringing Arm to Z systems.
As a virtualized.
So, and Z is the most legacy hardware, focused hardware that you can find anywhere.
Now, don't get me wrong. That announcement between IBM and Arm is great.
Really cool.
Really cool.
Really cool.
You're emulating Arm on the Z architecture.
It's not emulation. If you read the notes, it's not emulation. There's literally start Arm execution instructions that they're adding to Z. This is going to be your dual decode system. What they're leveraging is Z's hypervisor, because Z has been under a hypervisor for years. So what you can do is launch an ARM VM, effectively. So
it's still a virtualized machine. But
it's run native. The instructions are native.
On Telum 2, or are we talking about future?
Well, Z18 next gen.
Okay, next gen. Okay.
Yeah, next gen. Okay. This is not a current thing. This is a next gen thing. So really awesome, but it also completely countermanded what Mohammed said on stage about not having to support legacy.
No, it's the right argument for the right audience. You don't need to confuse these things, George. Right? All these value propositions and arguments exist in isolation. How dare you draw a line between them? How dare you?
It's my job.
No, but stick to your lane, you asshole. Stick to your lane.
Yeah.
Well, I mean, this is also the old Intel argument of glue bad.
Yeah, and we'll talk about what has changed. Well, actually, you know what? Let's talk about that right now.
I do want to say, one thing.
Okay.
They had a number of partners on here. It looks like ARM has leveraged the physical design services of both Broadcom and Socionext.
They have not, at least according to Renee. Renee said that it was all done in house, including the physical design.
I doubt that.
I was right next to Max when he asked this.
Let's put it this way: the investors don't believe that.
I'm just saying what was said.
Given how much that Broadcom was on stage, as part of the announcement. I don't believe that. And the reason why I want to add on top of that is we know who the main customer for this is.
Meta.
It's Meta, right? Meta extensively uses Broadcom for their in-house AI accelerators. This would be one of them. And if I focus when I zoom in, those words there say Broadcom. I mean, it's the size of ravioli on the screen. This is engineering sample that shouldn't have been on eBay. Because people like me buy it. But it's it would make sense, right? It's why would you have a
that's why I thought that's why it was asked, because Broadcom showed up. So or Broadcom do apparently not. Now if ARM wants to correct this, they can, but apparently from Renee, it was done in-house. So
it's well, I mean, we'll find out once the chips get launched, because we'll find out, are they using a Broadcom PCIe IP sort of thing,
or if they're using like Synopsys or even their own.
Well, so if you use Broadcom design services, you have to use Broadcom's PCIe IP, that sort of thing. It's tie-in, it's vendor tie-in. So but coming back to Meta, right? All out of all the hyperscalers, let's list off their ARM-based CPUs, right? Amazon has Graviton. Google has Axion. Microsoft has Cobalt. Right? Meta never had an ARM CPU program, or at least not one that made anything.
Well, the interesting thing is, who did Meta buy fairly recently?
Well, no.
About
who did that?
7-8 months ago. It was announced at ITT, or roughly around ITT 2025.
I can't remember. Remind me.
Rivios. RISC-V CPUs.
I thought that was Qualcomm bought Rivos.
No, Qualcomm bought Ventana.
Yeah, okay.
Rivios was bought by Meta.
The thing is, Rivos wasn't working on a proper CPU at that point. They're working on an accelerator. And the argument at the time was that Meta has two workloads, right? One is recommendation, which is what the MTIA is for. And the other one is large language models. Ideally, you would want one chip to do both, but Meta really needs two chips, and Rivos was for the large language model side of that. So I don't think that necessarily applies here. But my argument being is Meta is the only one out of the major hyperscalers. Otto said Huawei. Huawei has Kunpeng.
Yeah.
And I think you've even got one there, haven't you? Or you have had...
So our mutual friend Brutus has a NIC that has a Kunpeng.
Yeah.
That uses a Kunpeng server chiplet, basically.
They also do Kunpeng embedded chips now as well, so you can buy those. So rather than Meta building their own ARM CPU, and let's be honest, most of the other hyperscalers just use an ARM CSS plus extras. Even Nvidia with Grace.
No, that was not CSS.
No, but it's just before CSS came in. It's but then and the thing is, the hyperscaler that needed an ARM CPU is Meta, so they went to ARM and said, "Build me a CPU." And as a result, so it was advertised, and Sally corrected me on the side. It was initially thought, okay, this is ARM competing against its clients. Whereas no, they're saying this is more like an offering like a microcontroller. So it's only going to go to customers who ARM will work closely with to help build out their infrastructure. So ARM, OpenAI, and I don't think it'll end up going to anyone else, because it's not a product they're going to stick into a server for people to develop on. It's not going to end up in a small box on your desk.
No.
They're not going to ship any out to review.
So
if somehow Azure gets some of them and makes instances or something, I'd be surprised.
Well, so they are shipping it to Supermicro and Lenovo.
Yeah,
And they're
but again,
building.
but Meta, for example, X uses Supermicro servers,
Mhm.
right? Meta doesn't do all their in-house server design.
No, but this is like, if you go to Supermicro site, it will say "coming soon." Like you will be able to buy it. Just hand money over and buy it as a dual CPU system.
Coming soon to pre-approved customers. By the way, the approval process is through ARM.
But my point is that, in theory at least, you should be able to buy this on the open market.
It would be nice. I don't think it would get there.
So, but there is one thing on this slide that I do kind of want to tackle, and this will go into what I'll talk about later a bit more. But available now, what they actually mean is available to order now for their leading partners.
Who are involved in the co-design anyway.
Yeah.
So
this will actually be GA or general availability at the end of the year.
Yeah, so ramp in the second half.
Yeah.
Available now, but ramp in the second half.
Yeah, so what they should really be comparing, like what this is actually competing against in terms of CPU v CPU, if you want to go down the x86 route, is AMD Venice and Intel Diamond Rapids.
That's in terms of when it's coming out. In terms of performance. So that's part of the other issue. ARM is very clearly not used to launching a product because a core, yes, a product, maybe.
Yeah, that's not who I want. Yeah, there. I just sent you a slide deck. It's similar to the one that it may be the same one that you have. But if you scroll down to page 17 in that slide deck, there is this slide of performance. And there's a lot of issues here with the slide. Firstly, when it says x86 CPU, what they mean, the actual CPU that they compared to was the AMD EPYC 9755. So that is AMD's high-end 128 core CPU. They didn't compare this to something like Clearwater Forest, which technically isn't out yet, so I can give them slack there, or isn't generally available yet. So, but the other competitor is the AMD EPYC 9965, which I would argue is actually more of a competitor to this than the 9755. And in some regards, the SKU just below it, the 9845 or whatever it's called, is sort of where you should be looking at in terms of comparison versus AMD. But that was not the comparison that ARM made. ARM made it versus the 9755. Okay.
For some reason, it's taking... Discord does not like your PDF. It downloaded all the others immediately.
Huh. Okay.
And it keeps stopping and resuming and stopping and resuming.
Okay, you know what? I just need... Worked for me. Okay. But anyway, because I accidentally re-downloaded it. Here, I'll just pull up just send you the image. There we go.
Every time I keep trying to re-download it, it pulls from the cache, even though I've told it not to.
That's the image.
Yeah, give us a second. Maybe Discord's having a Mardy. Yeah, I wouldn't put it past it. Yeah. Do we have enough image space?
Anyway, so
This one.
yes. Okay. So mind you, this comparison is against the 9755. So that is a 128 core, 500 watt CPU. Here's the issue with this slide. What programs did you run? What tests did you run? What's the hardware configuration? What software did you use? There's a ton of questions to this single slide, and there are no endnotes. Unlike AMD presentations or Intel presentations, there's no endnotes. It's just this slide. So, it's just bars on a graph. There's not enough information for me to really say one way or another how this actually competes. And then some of the wording on here, like sustained threads per rack, what exactly does that mean? They never expanded on that. And it's a bit odd.
Yeah.
So
Well,
it's very much, ARM does not know how to sell a product.
You know what it is? It's the same issue we had back at Anantech, right? You would make a graph and you would say what the graph represents in the words around it. But if that graph gets picked in isolation and dropped into a Chinese forum,
yeah,
you need to have all the relevant information on the graph to make the graph individually worthwhile. If you stand up there and as a presentation describe what the graph shows, then you are left at the whim of people taking the graph and not the presentation. Because let's be honest, who's taking a presentation?
Yeah.
And printing it out for their boss? No.
Yeah.
So it's along those lines, right?
Yeah.
It's the thing is, when you're dealing with 136 cores at 300 watts versus 128 cores at 500, and the frequencies therein, again, one argument could be here. Well, perhaps the workload was memory dependent, or perhaps the workload was PCIe dependent, or any sort of numbers. And this is the reason why we go back to, an AMD and Intel are getting pretty good at this. They tell us what software they're using, what version, what drivers are installed, exactly what memory is installed, whether it's single rank, dual rank, MR DIMMs, Mr. DIMMs, whatever. Then, what kernel, what version of the kernel, what software they're using, how it's compiled, what flags they use to compile it, what the workload generators are doing. And why? Because we've spent the best part of 20 years banging it into them that this is the sort of stuff we need. Yeah. Because when you go submit to Spec or MLPerf, you have to provide all this information, right? And the thing is, in the event, did you see a live demo?
They did have a live demo. However, that live demo only had 6 memory channels populated.
So what was the live demo running on a local system, or was it running in a system back at?
It was a system that was supposedly in the building somewhere.
Yeah. So
it wasn't in front of me, if that's what you're asking.
The reason why I say that is because there's 3 little words based on the bottom right.
Yeah, based on estimates.
Yeah. It's I take with a lump of seawater.
Yeah. And now let's get to the thing that really got under my skin.
Yeah,
So-
let me see. Let me see if I can share a thing for this.
Because we keep saying that this is a 300-watt CPU. Let's put a caveat on that. Because this was the first product briefing or product. So this product brief actually has more information than the slide deck.
So explain to people who haven't seen this before, what's a product brief?
So a product brief is basically a one-page or a two-page PDF that says what the product is and what the specs are.
And roughly what verticals it should be aimed for,
Yeah.
or some of the philosophy behind the design. It's a mixture of word plus data, or it should be.
Yeah. It basically condenses everything down into 3 pages about a product.
Mm-hmm.
So there's the introduction, cool, high performance CPU, awesome. Page 3. Okay. Page 3 has the spec sheet for the ARM AGI CPU. And if you notice, I'll sort of go back to what I said before. In here, you'll see that it says CXL 3.0 Type 3. That is 1, 2, and 3. So there is an error on this slide, on this product page that got corrected. Awesome. Now, another thing, and this goes back to what I said before about how...
Well, hang on. Let's explain what's in front of us first.
Yeah,
the CPU will be offered in 3 different SKUs.
Yeah, so it will be offered in 3 different SKUs, a 136-core SKU, a 128-core SKU, and a 64-core SKU. The name at the top is incorrect for that middle one, but...
What I think this means is there's 136 physical cores, but for yield issues, 128 will be the highest volume part.
That's what they're calling the TCO optimized. In the later product briefs, you'll see as TCO optimized.
Yeah.
And then you have the max memory per core.
Oh,
However,
yeah,
going back to a comment that I made earlier about how this is notionally the same core that is found in Graviton and Cobalt, that isn't strictly true. If you look at the underneath the core count, it says 2 by 128 SVE. What this means is this has 2 128-bit SVE pipes. So that's their vector, equivalent to AVX on x86. However, Cobalt and Graviton have both chosen to go with 4 128-bit SVE units. And as far as Cobalt is concerned, we don't know about Graviton. They have 3 megabytes of L2 per core instead of ARM's 2 megabytes per core. So the vector and general workload performance, assuming you're going out to L3, will be reduced compared to Graviton or Cobalt.
But we've managed to fit more cores in.
No, Graviton has a 192 and Cobalt is 132, which is close enough.
I mean,
So,
per unit die area?
per unit die area, probably. We don't know the die size of the other two. We do actually know the rough die size of each of these dies. It's about 400.
Okay, so
about
they're
400 millimeter.
They're not reticle busting yet.
No, but there's about 800 millimeters squared of N3P on each of these packages. Now, going past the L3, we get to the frequency. Now, here, they said in their presentation up to 3.7, and that's perfectly okay. I am okay with them saying up to 3.7 because they have a SKU that hits 3.7. But they also have their base frequencies. Cool? Awesome. Okay. So they have a base frequency of 3.2 for their 136 and 128 cores, and then 3.5 as their base for the 64 core SKU. with the boost clocks being 3.5 for the higher core counts and the 64 core going up to 3.7. Awesome. This is where I stirred up a bit of a shitstorm. Was right here with this TDP range, because I went to ARM. We were in the Q&A, and I asked, "Hey, I see on your product brief up to 420 watts," and they look at me like I'm crazy, and they're like, "No, it's 300. It's 300." I'm like, "Okay." Well, I see it here. I'll show later, but okay, cool. So the PR lady comes up to me and is like, "Hey, can you show me where you see that?" I'm like, "It's on your website. It's on your page. It's right here." She's like, "Oh, okay, cool." So they go off to go figure out what happened. Okay, so I'm talking with I think it was Fudo at the time, another member of another analyst. And one of the PR people comes to me and says, "Hey, we've fixed it. We've just said 300 to make it clear that it's 300." And I said, "Wait, hold on. Can it still go up to 420 watts?" And they're like, "Well, you can set it to 420 watts." I'm like, "Okay, no. This is now a 420 watt CPU then."
It's the technically with an Intel CPU you can set it to 1,000 watts, but it may only use 250 at most. So if in the BIOS you can set it to 420, but at full rate, if depending on the frequency boost algorithm and what have you, if it only hits 3.2 core, then maybe it doesn't go above 300 technically in a workload.
Yeah.
So then why just because you can set a number does not mean that that's its value.
No, but the thing is that they changed it to just say 300. And that I consider a bit of a problem, because you can set it to 420 watts, right? So it is an up to 420 watt CPU. You could say default, like if they had added a little section that just said default CPU, default TDP.
If it's the you give 5% more information, we'll understand it 100% better. But instead, you've taken away 5% of information, we understand it 100% less.
This is the same criticism that I gave of Ampere with their usage power. Just give me a TDP number, even if, like,
the average, it's like total board power versus total design power. Because you also sent me this. This is the -2.
So no, there's the -1 first.
Okay,
there's the -1 first.
Right, so this is the updated one.
Is that
that's the -1? Yeah.
One. Oh,
you can see it top left says -1.
Yeah, that may not be the right one. Hold on.
I've got a no dash, a -1, and a -2.
Okay. Let me re-download it.
Just call it -3, just in case.
The newest PDF I sent you.
Okay. The thing is, if the numbers you are using in your estimated performance and performance per core and performance per watt are based on power, based on a theoretical peak power or a theoretical average use power. So this is. So we've still got the error at the top where they've failed to call this the 128.
Yep. But if you notice, the frequency has now changed. It's now 3.2 across the board. Yep. And the TDP is just 300 watts.
Yeah.
So between this and the final version that's currently up, there was a second change. But they didn't So if you go back to the other one,
Okay.
they got rid of the product brief for a while. It disappeared. And then the lower two SKUs also disappeared. They only had the 136 core on their site. The 128 and the 64 core SKUs disappeared for at least a week or so. Like, they were gone.
Down for maintenance.
Basically. So there was only the 136 core that was up. And then we got the new one, which is the Dash 2, which has the maximum frequency of 3.5, 3.5, and 3.7, and then the base TDP with an asterisk, and the asterisk says if you go down to the represents a preset value within the configurable TDP range.
So at the top here, on page 1, where it says a 300 watt TDP enables a deployment, they could have picked 250. They could have picked 400. I could have picked banana.
Yeah. Now, what I will say is that ARM was very insistent that all of their performance numbers were done at 3.2 gigahertz and 300 watts. To
be honest, they could have been.
Well, yeah, I will give them the benefit of doubt on that. That they ran it at 3.2 and 300 for their performance numbers. Mm-hmm. But all this changing of the spec, I wrote. So not only do I write, or am I part of Chips and Cheese, in order to pay the bills, I do write for Tech Insights. And the headline that I have is the utterly unnecessary marketing bollocks. That is the subtitle. I expect it to change.
Hang on.
But I was frustrated enough with this.
Right. So did you say bullocks or bollocks?
Bollocks.
With an O, not with a U.
With an O.
Okay. Sometimes Americans think they're the same thing. It's not.
No. BOLLOCKS.
Good. As long as you don't call it the dog's bollocks, you're fine.
No, because that means that it's the greatest thing ever. If I remember. Yeah. No. This is
Can I give ARM a reprieve?
Okay.
They did something. They corrected a thing that annoys me to no end. Right. So in the original, they've got 3.2, 3.5 gigahertz. Right. In the latest, they've got 3.5 gigahertz. You know what pleases me greatly? That space. There should be a space between your number and your unit.
Yeah, there should be.
So it's I mean, if I remember correctly, the version of the spec sheet I saw and I shared around was essentially this, but it said 3.2, 3.5, 3.2, 3.5, 3.2, or 3.5.
I think you had the original version, the very first one. Because that was what was available on launch day or announcement day.
No, I think that's what I saw on the website. Hang on, let me check. Yeah, that's just a press release. I got multiple versions of the press release. They didn't ask for my quote. Who did they ask for a quote? Yeah. Okay. Yeah. No. It's. I think I pasted something on Twitter. I think from the website at the time. It's
so. Again, I understand that ARM is not used to making their own product, so I'm not trying to be mean here. I'm just trying to point out what could be improved for next time, because this changing of the spec was really frustrating for me. As somebody who delves into the spec and writes about it,
so
this was frustrating.
It's So don't get me wrong. Me being an analyst and trying to help companies with technical marketing, I'm dealing with this stuff day in day out, right? And the only effective way I've shown for companies to understand this is to go from the point of view of what happens when somebody misinterprets it. However, that's a double-edged sword, because sometimes, depending on who you're speaking to, the fallback is to, well, give them less information. Sometimes less information makes it easier to understand. What I have a feeling here is that while you and I deal with marketing team from AMD, Nvidia, Intel, IBM even, right? We have worked with them for years. They understand what we want to hear. They understand. They know what we know. They know that we can explain that to our audience. They know that people like Max and Tobias can explain it to their audience. Or if not, they'll ask somebody who is more understanding. I mean, I've had plenty of calls with Max and Stephen at Reuters.
I mean, Tobias and I talk almost weekly. Yeah,
it's well, and Tobias is fairly knowledgeable anyway. It's the mixture of a first launch like this, plus with blinkers on, right? Because I would argue that they don't realize how much we know from dealing with their competitors, right? So they have to take it from the point of view of, well, what if they don't understand anything? Now, don't get me wrong. They know what we deal with them on cores, right, on IP. So we understand the IP level. But it's same. Arm is like a lot of other companies. Speaking with the engineers and speaking with comms, it's two different languages. Even if you're speaking about the same thing.
And I will say that they didn't really have anyone super duper technical there at the I was asking questions that were having to go out to be answered, they did it at Fort Mason in San Francisco, right? Yes. Now, bearing in mind that Arm's major CPU design places are Cambridge and Austin, I've got a feeling this was done more for investors than for press. That is considering the amount of financial press that was there, this felt more like and they have to be an investor / financial day that was made into an event, like a launch event, because the title of it was Arm Everywhere, but we only really talked about Arm in a server context. So chances are there may have been a day 2 that you weren't invited to that was just for financial analysts. There was not, as far as I'm aware. The amount of events I've been to where I've not been aware. Fair. Or a day 0. And the thing is, the comms people that you and I deal with may not be involved in that at all. That may just be investor relations. It's that sort of thing. Okay. Or it may have been a customer-only day. Maybe. It does happen. But I did talk with Thomas from Positron. He's like, oh yeah, this was the event. I saw his photo. Yeah. It's like, this is the event, and then he left out. Like, it didn't seem like there was anything else before or after, but there could have been. Also, at that event, I was told by the Micron folks who were also there that I've been put on the list to go see the Fab in Idaho when that opens up. So that'll be my second Fab tour. Is that where? Did you speak to Alex or Mungshay? Mungshay, I believe. Okay. Yeah, it's. We did get a $5 super chat while we were speaking from Jay. I won't put it on screen because it does use an expletive. But he does say, right in the middle of the darkest, RAM-starved, it's so over. Tech Poutine is at long last back. Thank you, Jay. It's Thank you. We do try and provide. I'm on the road next week, so yeah, good luck. Oh God, where are you going? Cadence
is having their event next week.
Okay.
And then the week after that is TSMC Tech Symposium.
Oh yeah, Tech Symposium.
So
I would like to go to that, but
it's also Andes has their RISC-V Con or Andes Con or whatever they call it.
I'm surprised I wasn't invited to that, or we were invited to that.
So my event was, if you're in the area, come by. Not we will fly you out.
Okay.
Sort of thing. And you know, the Condor team. I've been speaking with people from the Condor team a bit recently, just to talk stuff, not to talk about them. So it's because obviously the moment ARM makes a noise, RISC-V tries to make an equal noise, right?
Yeah.
So there's also some other stuff going on while I'm there, doing some interviews and stuff.
Well, fun.
But yeah, no, Cadence should be fun. First time going to Cadence Live. I actually presented on stage at Synopsys a couple of weeks ago, Synopsys Converge. Sally and I did a version of the AI hardware show for that. We were the warm-up act for the keynote.
Nice.
So we were on stage at 8 a.m. after landing 4 p.m. the night before. No, it was fun. We had a good 50 minutes on stage, and then on came Synopsys CEO Sassine, and then at some point Jensen came on stage as well. So we can say we were the warm-up act for Jensen. Both Sally and I had individual panels later that week. I think they said something like 4,000 signups for the event between Synopsys. So Converge is 3 events really. It's the user group, Synopsys user group. That's like the engineers. The Synopsys Executive Forum, which is like the C-suite, and then there's ANSYS SimWorld, because they bought ANSYS.
Yeah,
they
did.
So that went on. That was my week before GTC thing. But Cadence, who is Synopsys's major competitor, it's their equivalent event next week. I'm not scheduled to do anything there, except meet people. And it's a 2-day event, not a 1-day event. But yeah, it should be fun. And we've actually just got another $10 chat from Jay. Thank you. He does have a question. In all the material I've read about Taalas, all I can find about how they handle context is we have SRAM. Ooh, that can't be enough. Do we know what the story is there? I can answer this. Do you want to?
So I know who's running Taalas. I don't know really the hardware.
You didn't get the briefing, right?
No.
Okay. So they recently announced, and this is actually one of our tech boxes, so maybe we can go into it now. Did we have a picture preloaded? Can we get that on? Yeah, give us a minute, we'll bring it up. So Taalas is a company that is pre-baking models into silicon. By which
so it's
I mean,
like etched,
but more extreme. So Etched is a company that says, we're going to build an ASIC that only does transformers. Taalas is a company that says, well, we're going to build an ASIC that only does your model. So if you have a super fine-tuned version of Llama 3, yep, we'll do that. Can it run anything else? No. The way they do this, that's the performance chart. Do we have the architecture or something else, Dom? And so the way they do it is they have a homogeneous architecture of SRAM-based ALUs. And when you know what model you want, they will go and put the upper metal layers on that chip. So they already make, the bottom 2, bottom 3 metal layers. and they'll have like a stack of those ready. And when you say we want a chip, they'll say okay, and in 4 weeks you can now get an optimized ASIC, like a Bitcoin mining ASIC, for your model. The upside is that in a 7 billion parameter model running on, I think, 2 chips, you can get 14,000 tokens per second. Let's see if I have a picture here. This is their artwork. Yeah, so this is their rough. You take your PyTorch model, and you in the middle here you have this sort of. These are how the nodes are connected. That's already baked in silicon, and then you put in your mold of what you want your model to be, and then out it comes. Oh, and that's a PNG, so we can't see what's going on with these numbers. Let's see if I can. And is the website down? Oh, this is annoying.
So, I think a question that.
Oh no, sorry, I can't spell. That's why.
Classic.
If you want to use this and run this, head on over to a website that is simply ChatJimmy.ai. This is a web interface to their API backend. And if you say, hi, how are you? $16,000 tokens per second. How do I build Python code to solve a 2D transverse Ising magnetism model? Show your working. And it's given me 1,000 tokens in 61 milliseconds. So that's including time to first token and tokens per second. This is still an early beta or even early alpha, but they've made open. The context length is only 6,000 tokens. I don't think they've said what model it is that they're running. It may even be a Quen 2.5 billion or whatever. But take that the fastest Groq can do, or Cerebrus, is anywhere between 1,600 and 2,000 tokens per second. This is 8 times faster, and I believe one chip is 50 watts.
So my question was going to be, how does this work in turn? Well, one, what happens if the model changes? Do you have to go buy? You have to go buy a new chip.
Yes.
Okay. How often is that expected?
So it depends what you're using it for, right? Imagine you are installing a fast food serving app. You have your optimized model. Do you really want to sit there updating it?
No.
Or do you want it to sit there for 10 years like an embedded system?
You want it to sit there.
Now, one could argue for the cost of Wi-Fi, why would you even buy a, you don't need 16,000 tokens per second at a McDonald's service station.
No.
But what if it wasn't a transformer? What if it was a telco? Or what if it's for a bank? Or what if it's for industrial, right? These sorts of things that have long service lives. But Taalas's argument is that how long was GPT 4.2? used for publicly? 12 months, 15 months? Maybe
12
less.
months, give or take.
Yeah, okay. So you bake in your model, you get chips a month later, and you use those chips for 11 months. You could use those chips for another 5 years if you still have a use for that model.
Mm-hmm.
But the time to get your chip is so quick, you're not paying the tax of being an architecture behind.
I will say that it does feel very, for lack of a better word, wasteful.
You could see that you would like fast fashion.
See,
the issue is we don't have any semblance of the longevity of these models yet because the industry is so fast paced.
Yeah, and maybe in 3 to 5 years we will have solidified down and will take longer in terms of model usage and all that, but I don't like the idea of making a piece of silicon and then a year later it's not just obsolete, it's functionally useless for anything else other than that one task.
Well, no, not the task, the model. You can chain models together into tasks.
Yeah.
And the model can do different things. It doesn't have to be a language model. It can be a vision model. It can be a recommendation engine. It can be...
So, excuse me. I could see this being useful for some vision models, because those are slower pace, as far as I'm aware, than LLMs.
Yeah. It's again, don't think about the iteration of development. It's about deployment. And the thing is, yeah, if this is 10 to 50 times cheaper, and you're running like again a GPT 4.2, we're in an industry where I'm not saying waste doesn't matter, but waste is a cost problem, not a nature problem.
As much as I hate that, you are correct.
Right? It's like energy, right? Energy is a cost problem. Not a nature problem at this point.
Yeah.
I would argue that in terms of waste, silicon waste is minimal from the chip itself. Now you got to think, well, does that mean I have to throw the board away? Does that mean I have to throw the motherboard away? Does that mean I have to throw the server away? And there's a good chance here the answer is no. Because if it's just a
PCIe card, if it's just on a standard PCIe board,
or it may even be a socketable processor.
Then it depends. That's a bit more dependent.
Taalas is still. I can't even remember if they've raised a Series A yet or not, and they already have silicon. Yeah. So Dom says what they're showing off is a PCIe card.
Okay. Then then you have your server. It's x86 or ARM based. That runs for 8 years, and you're just switching out PCIe cards.
Yeah, or you're running this model and this model and this model and this model, and you're chaining them together.
Yeah.
And that's your agentic flow, because it's running at 16,000 tokens per second. Now, so the architecture behind this is compute in memory. So they're actually doing compute in SRAM cells.
So like D matrix in that regard.
Yeah. I think what they told me is the current generation can do like 3-bit plus 3-bit. And next generation is going to be 4-bit plus 4-bit.
Okay.
And Dom's confirming here they're actually a Series B. They've raised 200 mil.
Oh, okay.
But that Series B is very recent.
Okay. Actually, I don't know if it was on the notes, but speaking of D matrix, they've purchased the fabric part of Giga.io.
So it's they've not acquired the full company then.
So what happened is
they've got a Groq.
Giga IO is now so you know that supercomputer in a box, the Griff.
The Griff, yes.
That's what Giga IO is now just selling. Just that.
Well, so for those who don't know, Giga IO is a company that basically tried to do CXL before CXL was a thing.
Yeah. And now they've sold that fabric part of the business to D-Matrix, which is an AI startup, similar to TensorTorrent or
not quite, but yes, in the
but like in terms of like business size in startup land and all that.
Yeah.
AI startup.
So it's which is, I mean, I've been speaking with the Giga IO guys before CXL was a thing. And I visited their offices up in Carlsbad. I even did a video about them when they first.
Oh, they're local to me. Oh, that's funny.
Yeah, they're in Carlsbad.
That's funny.
It's. I did notice that their senior technology team just announced a new startup. So here's me thinking that this has been on the cards for a while, and so everybody, I mean, as you say, if all they've done is acquire the IP, then a couple of the senior Giga IO people were kind of near retirement anyway. I was actually pinging them today, saying, "Hey, congratulations! What the hell?"
Yeah.
And they
That's
said,
kind of how I felt when I read the press release. I was like, "What?"
Well, one, why would D-Matrix want Giga IO, and two, good for Giga IO.
So it makes sense from the perspective of like scale up fabric.
Yeah.
But
let's see if I can do this. Yeah, so this is the former lead engineer of Giga IO is launching a new company called Exohelix today. With two key people from Giga IO. And the fact that it's today, right?
Yeah.
The same day, or the day after they announced that Giga IO is being acquired by D-Matrix.
Yeah, it was a couple days ago, but yeah. I know I got that email in my inbox. Like, what? I was not expecting this.
So
yeah.
As I said, D-Matrix as it's actually a company I'm starting to work with now, as a client, and they have this compute in memory architecture, which is actually really power efficient. But they're moving from integer into floating point, which is a stage up. But they're also one of the leading people working on stacked DRAM.
Yeah,
and
them and I was gonna say the.
So funny enough, I reached out to Preferred Networks while I was in Japan.
Oh, did you?
They didn't get back to me in time. But yeah, no, it's and their stacked DRAM is on 40 nanometer, just to be clear. Whereas D-Matrix is doing their own thing, and they're having to develop their a process that works with what they're doing. But they have a test chip. There's a lot more information going to come out from them this year, because part of the issue that I'm working through with them is their initial announcements into the space were a bit confusing. And then they launched a networking card.
Yeah, that did seem odd. Like sort of the series of events.
One thing that's going to be coming a lot of noise from them soon is the term speculative decoding, which they're really good at. So I'm going to be working with them on that. And now I know a bit about them, and it does look like it's got great potential. And that's kind of why I'm working with them. So
the question I have for a lot of these startups is how program? Because if the answer is just an API, that's not ideal, because then I'm having to rely on you to update that API with new models.
Well, a framework rather than an API, like a PyTorch, TensorFlow, and Onyx. You know, some are using JAX, and then if you're in China, there's Paddle and everything else. We are getting to a point where those who are able to be agile are now talking about being open on their low-level stuff. You know, TensorTorrent's been there for a long while. We're trying to get everybody else to do the same. The problem is, any chip in that space, any AI hardware startup that uses HBM, you're going to have a limit.
Comes to mind.
Furiosa, Rebellions, every Next Silicon. It means you're going to have a limited distribution of developers. People are going to have to buy into the idea before they deploy at scale, when realistically, ideally, you'd want it to be the other way around. So it's so we've got a few other topics here. I want to go over a few of some of these small ones, if you don't mind. Let's go back to LinkedIn, because a person who is very important in the industry is deciding to retire.
So Leslie Barnes, who is the head of cores, so the development of cores at AMD, is retiring.
CPU, CPU cores.
Yes. So he, as far as I'm aware, he is the lead on the Zen 6 family of cores in terms of the microarchitecture. AMD, if you're listening, I would really like an interview with Leslie before he leaves about Zen 6. That would be cool. But
Leslie's appearances publicly,
very few.
I've met him once.
I've met him twice, actually.
Okay.
I met him once at Hot Chips and very briefly at an AMD event. I think I met him very briefly at the Zen 5 launch event. And then I talked with him more at Hot Chips.
It's the if you were to draw a hierarchy in AMD's ecosystem, you've obviously got Lisa, who's the CEO. You've got Mark, who's the CTO. Then you've got Mike Clark, who's in charge of essentially the Zen SoCs. Full stop. And then you've got Leslie, who's in charge of the cores. Then you've got somebody else in charge of the fabric, somebody else in charge of graphics, somebody else in charge of different IP blocks and whatever. And he's been there since the Optron, maybe even before the Optron days.
He's been at AMD for 25 years.
And he's led the AMD cores team since 2020. So being involved in every major Zen launch that's reinvigorated the team. And this industry keeps alive and kicking, and everybody gets a year older every year. So eventually you just say, hey, I've made my money, let's go focus on family or whatever I want to do. Or they retire and then 2 weeks later end up at a startup. So it's, I mean, when I've spoken to Leslie, it's always been fun. He knew who I was and I knew who he was. And
Oh, he knew who I was.
Yeah. You're causing a lot of ag over at AMD, aren't you? Again.
No, actually, he commented on the Mike Clark interview, and so
but there's that as well.
But his replacement is going to be Suzanne Plummer, who worked on the first Zen 1, and is, from what I've heard, well regarded in AMD.
Yeah, she's been long time AMD as well. She's spent the last few years working on the GPU side of the business. So we're literally talking about the RDNA ALUs and optimizations thereof. But no, I don't think I've ever bumped into her. And again,
she is very private, from what I understand.
There's also a women in technology thing.
Mm-hmm.
You become too vocal and you get asked to do everything else. And as far as I understand it, she likes, this deep working. So yeah, she was a power PC design engineer for Motorola for 9 years.
And 88,000. Wow, that's a name I haven't heard in a while.
And then has been at AMD since 2002.
So nearly as long as Leslie. Wow.
And been a fellow since 2008. So, yeah, and CDNA, leader of CDNA.
Mm. She was maybe, I don't know exactly where it is, but Alan. She was in league with Alan Smith, who I believe is now the head of CDNA SoC.
Okay. And yeah, this is the post that she made.
Yeah.
As you can see, I'm only second connected to Suzanne, whereas I'm first connected to Leslie.
Yeah, I'm second to both Leslie and Suzanne. I probably should just send a request, but
yeah. But yeah, so it's always sad when senior leadership team leaves, but as we know, these they have to go on. So
actually, speaking of LinkedIn, our good friend Ronak is now at Matt X. I always want to say MATX, but that's incorrect.
To be honest, it might as well be. And that's a startup I haven't paid much attention to, but I know I can buy their stuff in China.
Oh, okay.
There's a lot of people moving in the last few weeks, and I've turned around and said, hey, we should talk. Which is annoying because I've still got to catch up on 6 weeks of emails. So next on my list of things to get excited about is, hey everybody, are you tired of PCIe 5? Well, PCIe 8 is almost ready.
PCIe 6 isn't even out yet, really.
It is in the enterprise. It is in FPGA.
Yeah, it technically is in the Nvidia ecosystem, but
yeah. So this is once again a doubling of bandwidth, and the special announcement has been version 0.3 of the PDK of the specification rather. It typically goes 0.1, 0.3, 0.5, 0.7, 0.9 final.
Yeah.
Of which up to 0.5, it can change a lot. After 0.5, it tends to be, let's try this in silicon, and then post-tune. So delivering 256 gigatransfers per second at 1 terabytes per second bidirectional in an X16 config. You could download the spec and everything else. The reason why I bring it up, and I think we need to re-add some images in here, is that I saw it in person.
Oh? Marvell?
At the Optical Fiber Conference. Optical Fiber Communications Conference, OFC. And so this is, I took a picture of some slides. I took a picture of the boards where they were running it. So PCIe as a spec, you can only go through the board so long before the signal disintegrates. And as you go faster, it gets worse. I don't know exactly how many thousandths of an inch PCIe 8 is spec'd for, but I think PCIe 5 is something like 4 inches.
Yeah, that sounds about right.
It's 4 inches at a like 32 dB loss motherboard, whatever that means. It's not listed as 4 inches. It's listed as 4,000 mils, not millimeters. A mil is 1,000th of an inch, because America. I assume because of America. It's probably because of Britain. So as PCIe 5 to PCIe 6, that's probably 3,000 mils. To PCIe 7, that's probably 2,000 mils. PCIe 8 is probably 1,000, whatever. And here we have also a timeline. This is the let's target calendar year 2029 to 2030. So what they're saying is this is the year of PCIe 6. In 2 years will be the year of PCIe 7, and in 2 years will be the year of PCIe 8. These are retimers. So these are, you get 2,000 mils on a motherboard. You need a retimer to go another 2,000 mils. And this is the demo board they showed. So what we have here is, oh, you're right, George, you've paused.
So I just got a notice on Discord saying that I broke Discord's community guidelines for violent and graphic content 3 days ago.
Were you sharing ARM's CPU product briefs again?
I was angry at them, yes, but that was in like DMs. And it was just frustration over what I was talking about. But like, I'm very confused.
I'm going to go back to speaking about the demo.
Yeah.
So this is what they said the demo was. It's so it's an early shuttle tape out, just showing that it works. The industry's first PCIe 8 live demo, and this is the image of what was on the screen at the time. Do I have a zoom in of that green box, Dom, as one of the images? Because it's showing here some of the numbers, and I don't know enough about analog communications to understand what a chunk of this means. Our good friend Irrational Analysis does, and he often, says that there's too many DFE taps or something.
There we go. I
So,
was trying to read it from the little tiny.
Yeah. So this is running for 2 days. It has a bit error rate of 9 times 10 to the negative 9, which is pretty cool. Which means what? 1 error in 100 million? Which, if you're running at 256 gigabits per second, there's actually quite a few errors per second.
Yeah.
But it's still enough to meet the spec. And yeah, it's saying here bits received, total errors. And yeah, the total, and it's running in PCIe mode. And I just thought this was really cool.
Yeah, I mean, has the PCIe 7 spec been fully announced?
Yes, I was in the I was quoted in the press release for that.
Oh yeah, I remember that. We did cover that.
So the thing I did see at OFC is PCIe 7 cables. 3 meter long PCIe 7 cables that were about that thick.
Insanity.
Now, active copper cables, they weigh, they consume power, but you get your signal. And companies like Credo are doing that sort of thing. So yeah, PCIe 8 spec. We covered Taalas. Memory prices on Raspberry Pis are crazy.
Yeah.
Have you been following this?
Yeah, no. They had announced the 3 gigabyte version for, what was it, $80, because the 16 gig version is $300.
Which is insane. Let's see here. Raspberry Pi's Ramageddon response includes a 3 gigabyte Pi, for $84. And by raising the 16GB Raspberry Pi 5 price to $305, this is from our good friends at Lilliputian. And I was watching some videos about this, and it came, and the recommendation was, do you really need a Raspberry Pi 4 when a Raspberry Zero W would do? Could you actually do you need Linux? If not, maybe an ESP32 is right for you. It's that sort of thing, right? Do you need a full OS just to control your RGB LEDs? Or, yeah. Actually, how much is a 16 gig stick of DDR5 these days?
A what?
160 bucks?
I think it's down to like 140.
You can get a 2x8 for 230. It's one of those things where if you buy more, it gets cheaper very quickly. Yeah, a 2x8 for 150. That's DDR4 3200.
Apparently, the memory prices are screwed up in my head.
It's one stick of 16 gig DDR5 6000 for 200, or a 2x8 for 220. I'm looking on Newegg. Now the thing is, they're not using DDR chips, right? Or what they're doing is they're putting it on, they're soldering it on the board.
No, it's LPDDR, I think.
Yeah, so yeah, it's an LPDDR chip, so the pricing is different. The thing is, with the volume that they do, I'm surprised it isn't a lot better. I was having this argument with in a meeting today. If you're a company that's making a processor, say like Rebellion, making a chip with HBM, if you go work with Broadcom, you're leveraging Broadcom's HBM supply. You don't need to go buy your own. They get the benefit of having to order in bulk for many customers, and they get the price benefits. It's how many Raspberry Pi 4s are sold each year? Any estimates?
Really? I was thinking it was higher than that.
So all of Raspberry Pi is 6 to 7 million units a year. But it's saying here that Pi 5 and 4 together were 7 million. And combine it with even older ones is 10 million.
You've only sold... Scroll up. If you
this is the AIO.
It says... Yeah, but it says with over 68 million units sold in total as of March 2025. So, for perspective, there have been less Pi sold in a longer span of time than PS5s.
Wait, does it say 68 million?
Yeah, it's 68 million.
Intel might sell that many Panther Lakes this year.
Yeah.
Mind you, I wonder what's going to happen to the volume once Qualcomm fires up the Arduino train.
Yeah, if Qualcomm does it right, then they could be a serious competitor to Raspberry Pi in the embedded and industrial space, which is a place that Pi is doing well right now.
My question for that is always, is the margin worth it? Is the profit margin for those chips worth it for a company like Qualcomm?
Well, that's up for Qualcomm to decide, to be frank.
So for people who don't know what I'm getting at, if you're a company and you make a certain amount of revenue and you have a certain amount of costs every year, and you work it out and your profit margin is 50 to 60%. Now, here comes along through your R&D a new product. That's great. You're going to take market share with it. However, the price you can sell it at and your cost to sell means the margin is only 30%. Your stockholders might see that as a negative impact to the business. Even if overall you are earning more money, because your average gross margin, your average percentage margin you have on your products decreases. And because you are a senior executive at the company and you are invested financially in the company's success, because that's how they get senior executives to stay, they give them stock. Do you want the value of your stock to go down even if the revenue of the company goes up? And so you'll hear about a lot of companies shedding low margin businesses even though they're profitable, because they're not additive to the corporate overall margin. You know, so Intel's done this, right? It's shed a few businesses where it's only 10, 20% margin, where when in reality they want more like 60. It's that sort of thing. And so there's also the time and the effort, because the idea is the higher the margin business you have, the more agile you can be, the quicker it is to ramp up new product. If you're running on wafer thin margins like 5%, like some of the Chinese OEMs do,
or the motherboard makers, like motherboard margins aren't that high.
It means you have to be really accurate with your volume manufacturing predictions, and you have to make those predictions 3 to 6 months out before you even sell the product. Do I make 10,000? Do I make 12,000? Do I make 11,500? Because if your margins are only 5%, you can't sit on much stock before it's actually a net negative. So business things to think about that aren't just simply, why is this CPU too expensive? Why is this memory too expensive? That sort of thing. But you got to argue Qualcomm had to have bought Arduino for a reason. Speaking of Intel, did we put it in here? Not the terafab thing, the reinvestment thing.
It was at the...
There. Yeah, it's been taken out of the doc, where it wasn't even in the doc in the first place. Do we have the link?
I thought it was in the doc.
It is in the intro.
Oh.
Let me...
Well, I was going to say...
It's right, I've got it.
Okay.
I'll bring it up. So one of the things that Intel's done over time is, because they needed cash, they sold parts of their businesses. Right? We know that they've sold a portion of Mobileye. They've also sold part of their is it their wafer design or their wafer management stuff in Germany?
Yeah.
And part of it is, a few years ago, they sold 49% of their Ireland Fab32, which is their leading edge fab in Ireland.
34,
sorry. And this is the fab that was the first to build Intel 4 and Intel 3.
This is still the high production or high
fab
volume production for those nodes.
Yes. That's not to say it won't be turned into 18A later or whatever. But they essentially, they found a venture capital company who bought 49% of the equity interest in that fab, which basically turns around and says, well, everything we make in that fab and sell, they would get a 49% equivalent of,
Mm-hmm.
you know, but also they were liable for 49% of the running costs, right? It's that sort of thing.
Mm-hmm.
Intel still technically owns it and manages it, but they own 49% of it. And I believe they sold it for $11.2 billion in 2024. So
Yes.
not even 2 years ago at most.
Mm-hmm.
The news this week is that Intel has bought back that stake due to business being good, basically.
So the deal was announced June 4th, 2024.
Yeah, so 23 months.
Yeah.
Or, 22 months.
Mm-hmm.
And the key number here is the repurchase
Was for
14.2. So it cost Intel $3 billion more than they sold it for, which means Apollo made $3 billion plus whatever they made during ownership. Yeah, but you take on the risk. If Intel had folded, Apollo lost all the money, sort of thing. Yes, April the 1st for a press release is a choice. Guess which rocket?
Yeah, I was going to say, guess what rocket also launched on April 1st?
And do you know how many reels I see that people say, but they're doing it from their bedroom, sort of thing?
Yeah.
Because it's fake. And so this is the most advanced fab in Europe as well.
Yes.
But Intel CFO, the reason why this is important is because the agreement was the right structure, the right time, and provided Intel with flexibility, i.e. didn't go dead, enabling us to accelerate critical initiatives. Today, we have a stronger balance sheet, improved financial discipline, i.e. we fired almost 50,000 people, and evolved business strategy. The purchase of the stake is funded through cash on hand and the issuance of new debt. Did you read this? Did you read this bit?
I just saw that, and I'm like, okay. This how
is
much
like
cash on hand does Intel have?
Well,
because this would imply that it has
8.
Yeah, I was going to say about 7.7 billion.
Yep. And the issuance of new debt. Well, I mean, Musk issued $44 billion debt to buy Twitter, right? So,
sure, but like,
the thing is, Intel expects to pay off this debt in the next 2 years. What I think this will do is, if Intel is actually in a very strong revenue position right now, if Intel financials on April 23rd, by the way.
Okay.
This may hide a high growth Intel under debt repayments.
Which, okay, why would you, okay, from a
Intel is getting their chips bill money. Yes.
Yeah, so wait. From the perspective of the financials, why would you want to hide a high growth Intel?
Because it lets you as an individual buy stock at the cheaper price, such that when the market finally this is a picture of me at the official opening of Fab34.
And I know exactly which one you are.
Yeah. How am I not the shortest there?
Because Dom is right next to you.
No.
Oh, is he not the one to the right?
I actually, I'm not even sure if that's meant to be public. Are there other images from that directory, Dom?
Anyway,
there's I think there's an events directory from 24 when I visited.
But
yeah,
it does feel weird.
Let's put it this way: we are not financial experts in charge of multi-billion-dollar companies. I mean, I am trying. I did just get my tax bill for the last 2 years. So
I had to submit my tax bill and cried.
Well, I mean,
because I had to realize that
it's a different thing here. And my accountant was sending me documents going, oh yeah, this is what we're putting in. Do you confirm? Do you agree? But hey, it's actually super busy time for work as well. I have to present at conferences. It's fun. What other? We've been going for a couple of hours. We've covered a lot of the smaller topics today because I think they had the most meat. I mean, we could talk about Nvidia investing $2 billion in Marvell, as part of Nvidia investing $2 billion in everyone.
Yeah, that seems to just be a Nvidia staple at this moment in time.
I mean, to be honest, that's an article that probably should be written. Where has Nvidia actually invested its money? $5 billion in Intel, $2 billion in Synopsys, $2 billion in Marvell. I think they put $2 billion into Coherent, $2 billion to what's Coherent's biggest competitor? Begins with an L.
I don't remember because I know Coherent because they're right here. They're literally right behind me.
Yeah, Lumentum, and then there's the. Oh,
wait, technically they're in front of me.
I will invest up to $100 billion into OpenAI when I see fit.
Yeah,
I get people confuse memorandum of understanding with actual
money
contracts.
Yeah,
because a signed contract has to be followed through.
To quote, I believe it was a U.S. Army general. An MRU is not the end all. It's barely the means to. It's not the end. It's barely the means to start.
It's a press release to confuse investors.
Yeah.
Because that's what you want, confused investors. So what I will say, and I'll get to you, Jay, in a second. We are coming up to financial season.
Oh, right? Yeah.
So I believe on my calendar I already have. So ASML is on the 15th. Intel is on the 23rd. ARM is on the 6th. I think I've got AMD's dates somewhere. Nvidia is always off by 6 weeks compared to everybody else, so don't worry about that. Now, Jay does ask, because we brought up NVLink Fusion and everything else, do we think N1X is significant? By N1X, he does mean here the supposed version of the GB10 DGX Spark that will go into laptops. I'm still of the opinion it's DOA.
So,
as in dead on arrival, that's what that means.
No, I know, but I think I would not be shocked if there's a product. I don't think
a mass-produced consumer laptop would be it.
I think it's going to be more Strix Halo-y or SD or X2EE-ish.
But hang on, we already have a Strix Halo thing. It's called DGX Spark.
No, I meant in laptops.
Or just DGX Spark without the ConnectX.
Basically, yeah.
That's essentially what it is. It's my argument has always been, if there is a laptop with an N1X inside GB10, is that an Nvidia product or is that a MediaTek product?
So, yeah, that's
Because
who's doing the marketing here? So,
because DGX Spark is an Nvidia product where MediaTek is just a third-party manufacturing partner, for lack of a better term. So same with Kaby Lake G. That was an Intel product, and AMD just sold them a chiplet. GB10, or DGX Spark, sorry, is an Nvidia product, and MediaTek just sold them a chiplet. If part of that agreement is, well, okay, but we get to buy your GPU chiplet and then sell notebooks, is this an arrangement where MediaTek or Nvidia has to go to the OEMs like Lenovo, like Dell, like Asus, like MSI, and say, hey, build a Windows on ARM system using our chip. By the way, all those optimizations that Qualcomm has done for Windows on Snapdragon, you're not going to be able to use those. By the way, the single core performance sucks for a consumer laptop.
It's fine.
For a premium experience consumer laptop. Oh, and by the way, the idle power is 25 watts.
Well, I hope it's not 25 watts, but
have you measured the idle of a Spark?
The issue is that the NICs don't idle, so you can't actually get a true idle of unless I somehow ripped out the CX7 or CX8 or whatever. I think it's the 7.
So Will, there's a problem here with Kaby Lake G. He says Kaby Lake G was so cool. From a typically mutual enemies working together, sure. From a driver update cycle, terrible. Because as an OEM product, HP would have to validate the drivers so you could install them on their system. They'd have to wait for Intel to give them a driver pack, and Intel would have to wait for AMD to provide the update. If you've ever had to wait, what was it? One of the Lenovo Go systems. Lenovo, the handhelds, the gaming handhelds. Lenovo no longer wishes to update the graphics drivers for that device. I was hearing this on PC World podcast during my walk this morning. If you want, you can't get the latest GPU drivers to that device because whoever makes the GPU can't give them to you directly. They have to go through Lenovo because it's a pre-approved driver process for that device. And Lenovo doesn't want to approve new drivers for that device on Windows. Apparently, it works better in Linux. So this is a problem with these sort of nested designs, right? So I'm even if N1X comes to market with a couple of key OEM partners behind it, the software ecosystem just isn't there.
Yeah.
And if that's an MediaTek product, they're going to find out very quickly. If it's an Nvidia product, well, either way, it's a massive hit to Nvidia's credibility. If they come out with a device. And the thing is, I see so many people online saying, wouldn't it be cool to have GB10 in a notebook? And my answer is
it any good?
What are you going to do with it?
Factor? So the hypothetical...
If you're going to use it like a Spark, fine.
The hypothetical is, oh, I can go buy this laptop and it has the same performance on paper as, let's say, a 5070M laptop, but I don't have to deal with Optimus and all that nonsense.
What if the spec sheet says TDP 50 watts to 220 watts? Sorry, I'm just referencing the crap we were doing back earlier. Again, it could be that sort of thing. It could be the TDP could be tuned down so far, but the tuning could be unbalanced because there's not a power balancing profile, or maybe there is. Does it work in Windows? Does it work with Windows on ARM? Right?
Dom says in the chat, as someone who used a Tegra 3 laptop, no, I don't want one. And Radix Griffin says, "Oh dear, Dom, I forgot those existed. I am so sorry."
So yeah, if it comes out, I don't see anything good coming out of it.
Windows on ARM, okay. Windows on Snapdragon works.
Yeah, Dom uses it as his backup video editing device. And on the road, it's ultralight. The battery life works. All the software we use is pretty much solid now. There's very few edge cases, but as always, there will be edge cases.
Yeah, and one of the things I could see, because this is something that Qualcomm didn't really focus on, is gaming. And by that, I mean not at the level that Nvidia does gaming.
No.
And there is a question of how many games are just not going to work or not work properly.
That's what Proton's for. SteamOS.
Yes, but this is Windows.
Okay. Maybe I'm thinking about it all wrong. N1X is just the Steam Machine V2. The Gabe box. That's Gabe, G-A-B-E.
Yeah.
Box. Not what you thought I had said.
No, I knew what you said. It's just the other thing popped in my head as well.
Yeah. It says a guy with the Dell sex machine.
And the Hawaiian shirt.
Yeah. Yeah. I'm sure you've seen this recently. The numbers on the Steam survey for gaming on Linux have gone up to something like 5%.
Yeah.
From 3%. Now, part of it is apparently due to how they detect Linux in China. Because I also heard that if you just focus on English installs, it's 11%. Which seems high to me, but that's what Wendell said apparently.
That does seem high.
If somebody turned around to me and said, "Hey, this M1X in laptops, all it's going to be is a gaming on Linux machine," that also just does some AI stuff. The moment you install Windows on it,
goes out the window.
Yeah. However, if you don't install Windows on it,
why are you putting it into a laptop?
You've lost 95% of your potential market, and pretty much all of your enterprise market. That being said, you could argue that Qualcomm is focusing exclusively on the enterprise market, or 95% on the enterprise market. So why not go after the other? Why not go after the consumer market? Again,
of the two, Nvidia is better placed to go after that consumer market,
but not with that CPU.
No, especially because
I recommend that somebody build a 5.5-inch flip-up screen add-on for the Spark, like you used to get for the GameCube, and then build a 99-watt battery. Yeah,
I already have the 14-inch screen right here.
Yeah, just Type-C it.
It's already Type-C.
No, that's what I mean. Just plug it in via Type-C, and yeah,
it's plugged in via Type-C.
Yeah, that's what I mean.
Yeah. So, but
it's Cheng says, do VMs count in the Steam survey? Yes. if you see a single core Threadripper on the Seam survey.
Yeah.
And as always, the Steam survey always pops up when I'm on my lowest performing machine that I have Steam installed on. Like, this is not fair. I game on this machine maybe 60 minutes a month. Not my massive system that I game, 20 to 40 hours a month on.
Yeah.
So,
But
we also had Nvidia Groq in the list. I feel like that's been done to death at this point.
So actually, there is one thing that I did want to talk about very briefly, and that is sort of harking back to the ARM discussion. Nvidia didn't really talk about Vera and the underlying Vera CPU architecture very much, if at all, really. Like, it has SMT. We know its cache sizes, and that's really about it.
Well, so what we do know is that it's a custom ARM microarchitecture.
Yeah, but they haven't really talked about it much.
So we don't know how wide it is. We don't know decode length. We don't know the ALU config. We don't know the cache config.
They did say the decode width, which is 10 wide. But other than that, like, so we know the decode width.
Isn't that ARM levels of decode?
Yeah, it's about standard.
Okay. So what I'm showing up here is the roadmap.
Yeah. Also, if I may nitpick this name, why did you name it Rosa, Nvidia? Joan was right there. Joan Feynman, Richard Feynman's sister. Like, I get, you don't want to call your CPU Richard because Dick is a nickname for Richard. Fine, whatever. But Joan is right there. And Joan Feynman is a well-respected and highly accomplished astrophysicist in her own right. It was right there.
Who's Rosa meant to be?
Rosalie. My brain is.
So it shows you my knowledge.
Rosalind Franklin, who chemist and X-ray crystallographer, did a lot in terms of the structure of DNA, and
she was the Watson and Crick who didn't get the didn't get the award. Yeah. Okay. So I think it's better that it's her. Chemist.
I still think that if you're gonna have the GPU name Feynman,
don't forget there was some amount of controversy about them calling the GPU Richard Feynman.
That's also another reason why they could have done Joan.
No, okay. Flip it on its head. That's not Richard Feynman. It's Joan Feynman for the GPU. Yeah, that's fine. We get an all-female lineup for Nvidia in the next generation, or N+2 generation.
Yeah.
A woman getting an award, whatever next. It's, yeah. Annoyingly, in the tech industry, it's like that. This is why when I do my interviews, I try and make the interviews on my channel gender balanced. It's so difficult. A company will say, "Hey, do you want to interview so and so about this video on whatever?" And I'll turn around and say, "I like my channel to be gender balanced. Do you have any female engineers I can speak to?" And the answer is what? We've never had this request before. I was actually editing an interview today with a very well-known person in the industry. I won't say his name. But I noticed whenever he spoke about engineers, he always spoke about it using male pronouns. Again, subconscious cognitive biases that we have sometimes. And yeah, it's unfortunate.
Yeah.
Yeah. But what we have to do is basically say and correct everybody when they say Richard Feynman.
Yeah, no, it's Joan Feynman.
Joan Feynman.
Yeah, but
yeah. But yeah, this is the roadmap.
Yeah.
And the Groq is the LP line.
LPX.
Well, it's LP30, LP35.
Oh
LP4.
yeah, yeah, and then the thing is actually called LPX.
And to be honest, I don't think it's that much of an important add to the to the ecosystem until the NVLink model.
So I was talking with Tobias about this, and he said that it's only doing the FFN or the forward.
Yes.
The
forward feed network.
Yes, thank you. That I don't know enough to say if this makes sense or not.
So the argument is the forward feed network needs the high memory bandwidth. The question is always, well, how much memory capacity does it need? Because these chips only have 500 megs.
Mm-hmm.
Well, if you're doing a trillion parameter model, turns out you need 3,000 chips.
I haven't done. So I did a little bit of math, and a Groq 3 LPX, the LP30,
yep,
has 150 terabytes per second of SRAM bandwidth.
Correct.
And SRAM is functioning as effectively, you can think of it as their register file, because that's where they're storing all of their data, just in general.
It's a scratch pad, not a cache.
Yeah, it's a scratch pad. But if you actually do the numbers, MI 355X has roughly 160 terabytes per second of register file bandwidth.
Mm-hmm. It doesn't have 500 megs of scratch pad.
It's 128 megs, which true is not 512. It's not 500.
Yeah.
But you have the rest of the cache.
Dom, the difference between a scratch pad and a cache is that a scratch pad you write to, whereas a cache is like is a staged thing to main memory. Right?
So think of scratch pad as manual and cache as automatic.
Yeah, but scratch pad doesn't have layers of caching; it's direct.
Mm-hmm.
So you have direct access to scratch pad at a fixed latency, unless you're crossing a scratch pad boundary, cache line boundary, whatever. But with a cache, you don't know, when you grab a cache line for main memory, you don't know whether it's coming from L1, L2, L3, DRAM. And that's why a CPU core is designed to hide that latency as it fetches memory. With scratch pad, it gives you the ability to be deterministic. By which I mean you know exactly where your data is when at any given cycle. And that's actually one of the key benefits of the Groq chip and the Groq compiler, is you know where every bit of data is going to be at compile time.
So the thing is that you can set up a GPU just like that. That's just not the way that it's really meant to be used.
So a GPU L2, yes. Main memory, no. Because main memory still acts like a cache.
Sure, but remove main memory, and you're effectively talking about.
Another way to think about it is: do you remember Optane DRAM?
Yes.
Right. There was a way you could operate Optane DRAM as an SSD.
Yep.
As a scratch pad.
I was trying to find my stick of Octane, but it's not
Yeah,
here.
but that's essentially what it is. Imagine it like just a big SSD rather than a DRAM.
Mm-hmm.
But the fast, it's only 2 or 3 cycle access, or 1 cycle access for registers. And I think in the Groq design, it's either 1 or 2.
Yeah, it's just I'm not an ML person.
I bet if you approached AMD with a prospective white paper on this, they might pay you for it.
Let me put it this way. I am not the person on the CNC team that is capable of writing that. I just don't really see...
Well, let's put it this way. You can't access Discord, so you might as well.
True. No, but actually, I'm currently writing about the IBM Arm thing for Tech Insights right now.
Okay. Yeah.
Because that's cool, and I want to talk about it. I just don't see the advantage of going off chip. But anyway.
This one. D Cheng says, any news about IFS? I haven't paid attention much. No.
Well, other than the buying back of the 49% share, but honestly,
it's about this time of the year that the foundries start having their yearly events. Like I say, TSMC is in a couple of weeks. Samsung, I think, is at the end of May. Global Foundries is in August. We haven't had any word about Intel yet. For a while, they did have an event listed in August. Sorry, in April. Sorry, in March.
Get that.
But that came and went, and nobody said a thing. So, it's IFS. They've had a couple more people leave recently, and maybe in the last Poutine we mentioned Kevin O'Buckley left.
Yep.
As far as I understand, that position is being replaced. Somebody who'd come over from TSMC, a guy called Hon Han, I think. He'd been there for like the last 5-6 years. He's just also left. It's Naga. I think his last name is Chandareska. He's the person who's overseeing it all. And I haven't spoken to him recently, actually. But I haven't spoken to anybody at Intel recently because there's not been much to talk about. We saw the 200. Was it the 200S Ultra?
Yeah. You mean these?
The refreshes. Mine are in the post because they forgot to put me on the sampling list.
These that I haven't even tested because I don't have a Z890 board.
Oh, we do. We had to buy one.
Yeah, I have to go buy one.
So what 2 SKUs are they?
The Ultra 7 is the Ultra. It's the Intel Core Ultra 270K plus, and then the Ultra 5 is the 250K plus. And if you want my opinions, even though I haven't tested them, I've seen enough data. If you're just gaming, best CPU per dollar, period. The Ultra 5.
Yep.
If you're doing like workstation-y things as well as gaming, Ultra 7. $300 US, $200 US.
Just make sure you budget for memory.
Or is it $250? Really good per dollar.
Yeah. It's just a shame the macroeconomic situation is the way it is. $10 from Schmid. Thank you very much. He says, thanks, Chester, for dropping that split locks right up at 12:50 in the morning. Kept me up reading and musing about it. I read most of it. That was pretty fun. Dealing with locks across cache lines and how different architectures deal with it.
I will say the April Fool's article was a goodie. That was funny.
We don't talk about April Fools on this channel.
No, this was using Claude C, the Claude C compiler, and looking at how it performs versus GCC.
Okay.
It was very funny because IPC went up, but performance went way down because people think IPC and performance are inherently linked, and they aren't.
Yeah.
You can have really high IPC, but your performance can be in the gutter.
Are you familiar with Laurie Wired?
Yes.
She posted a video. Let's see if I can get this. Chrome doesn't like profiles properly. StreamYard. Can I share this at a stage? Let's go with there.
Is this DRAM history?
Yeah, let me go to my picture first. So one of the issues with memory, DRAM, is that you have to refresh it frequently. And you refresh it because the data in the cells degrade. Now the question is, how frequently do the data in the cells degrade?
Mm-hmm.
And the point is, you refresh the whole lot on a worst case scenario. So if you look here, the retention profile of DRAM, most cells will keep their data for at least 256 milliseconds. There is 1% that will do it between 128 to 256 milliseconds. And then 1% of that is essentially is 64 to 128 milliseconds.
Mm-hmm.
As a result, in order for you to refresh, you have to refresh your memory every 64 milliseconds. Now, refreshing takes a few hundreds of nanoseconds because you basically take the data off, flush, put the data back on. And this has been a thing in memory for ages. It's part of the fundamental aspect of the design of memory. What Laurie has done, and what's really annoying, is she's really good at telling a story. She's able to actually do a lot of build-up and suspense. Is that part of the research that she's done is by using a hedged read strategy, almost like prediction, you can reduce that. Whenever you read from a cell, it's not always constant. We know this. But imagine if you could guarantee a 99.99% latency. That's 15 times better than it is now. She's developed a software solution called TailSlayer, and it works across Intel, AMD, Graviton, using DDR4, DDR5, and an x86 ARM. It's just a C++ library. This is what I mean. She's good at telling a story. I mean, you won't see me, in a dress, in a chair, in black and white, rubbing my head. I'm not smart enough to do that sort of story. I've never met her in person, which is really weird.
I haven't either, so.
Well, I think she works in Seattle. That might be why. And doesn't work on Google Cloud, which is where I may see her or whatever. But no, it's really cool. She does some really interesting videos, and one of her off-the-cuff videos does more traffic than my best. So there's also a certain amount.
That's always frustrating.
And envious nature here. But the minute she posted this about the latency penalty, that's when I instantly thought of this slide from a 2012 lecture from Ona Mutlu at ETH Zurich. Because
I see. There's a couple of fans of him in chat.
Yeah. This is one of these core memories I have in my brain when speaking about memory refresh. I always bring this up. somebody says here, I thought you were an analyst. What does this picture mean in the context of your post? It's because it's a really cool image, dude. Yeah, and Laurie even responded. So that's cool. This is, again, part of my how do I get to 5 million interactions in 3 months on Twitter.
Well, you have 68K right there.
What am I on?
She asked Groq about it.
Okay, so for the past year, I'm at 8.9 mil. In the last 3 months, I've had 3 mil.
Mm.
And you see this big negative amount of unfollows I have on March 18th? That may have been DLSS 5 day. Where apparently I had a hot take that people didn't like.
Well,
I know. I'm one of the few people who saw it in person on the day, so.
Mm.
I'm the sort of person who still plays web-based HTML text games, so.
Yeah,
I used to be a clan gamer back in the old Battlefield 2048. 2248, whatever it was. Days. So I did game. People claimed that, is this guy even a gamer? I don't know. It's for me, the thing that matters most in my games is the detail high enough? Is the frame rate high enough? Do I like the game?
For me, it's just, do I like the game?
Yeah, it's Breath of Fire 4 just got re-released on Steam. So I'm kind of playing back through that right now. And the most annoying thing is it doesn't have a speed up function. You know, so I just load up something like Cheat Engine and double my gaming speed. Just because nobody got time for slow loading.
Yeah.
So yeah.
True.
I don't really have much more to say. I mean, yeah, we could speak about Sally at E-Time's got a great interview with Anush at AMD about CUDA. Yeah, people doing one bit. Yeah, people doing 1-bit LLMs, which is crazy. And apparently a school is doing overclocking competitions, offering CPUs and GPUs as prizes.
Okay, that's kind of cool.
What school is this? Oh, and they are actually using liquid nitrogen. Oh,
okay, that's neat.
It looks like somebody's showcasing a demo of liquid nitrogen. It looks like somebody who's involved in the overclocking scene helped to organize it. And there's a comment here. At my school, we weren't even allowed to use a browser.
Only Abacus is for you.
Yeah. Yeah. I'm actually getting extremely tired. I've been going to bed early recently. Trying to get back into a normal rhythm.
No, sorry. No normal rhythms allowed in this industry.
I got to pay taxes. It makes better to say it's better to have a regular time when I pay taxes.
True.
So, yeah, we didn't touch upon the semi-analysis thing. Stuff's going on. It sounds like they've got an injunction. They've got a court injunction on the guy that's suing them for him to remain silent because they claim he's got. Or the filings claim that he's still got a lot of proprietary information on a laptop he won't give back. He's claiming other things on the other side. So, yeah, there's no. I'm not a lawyer, so all I do is repeat what was said in the filings. I didn't say anything more than that. I did make a small mistake when I posted about it. I got the chronological order wrong of who filed what when, but I corrected that. My article is all up to date now. And I've adjusted the language for like a 4th time just to make sure that it's on the right side of legal and not impinging, not applying any opinion that I may or may not have, just to keep it fair to everyone. But yeah, it's next week we'll be on the same time zone.
Yes.
So maybe even Friday morning or something.
Okay.
Might have a poutine then. Or I may have to get a guest in. Let's see who's around.
I mean, I know that Tobias has been asking if he could come on.
I will say I've had companies say, "Can we come on? Can we come on? Can we come on?"
Mm-hmm.
And I'm wondering whether, for a fee, we let them come on for 15 minutes. And that's the sponsor segment of the.
Look, to be honest, like that I'll kind of
because this guy needs to put food on the table.
So, in full disclosure, if I do, as some people may know, when you turn 26 in the U.S., you get removed from your parents' healthcare insurance, and I unfortunately was removed, and I did not qualify for Medi-Cal/Medicare. So I currently don't have health insurance, which is a problem. So something I have been thinking about is if I have to take a full-time writing position at, say, Tech Insights or somewhere else, that would likely mean me leaving CNC as editor-in-chief. So
it's a money thing.
Yeah,
Davina, it's just a money thing. US being US and George being one fall away from a nasty break because his genetics are scraped from a barrel. I say that in the nicest possible way.
Yeah, I know.
It's,
and the funniest thing is, I was IV, so.
Yo, what? Sorry.
In vitro.
Oh.
So.
It's okay. My mother had me tested. I've got a certificate and everything.
So what's
and
funny
yes,
is so
as Davina said, eat healthy and get sleep.
Sleep? What's that?
Yeah, which is where I should be going.
Yeah. Because it's what, nearly 11 for you?
Yeah, which is late for me to go to bed this week. So, it's yeah, cool. Well, so with that, I'm going to wrap it up. We've got to do an ad spot saying buy merch, ring-a-ling the ding-a-ling. But you guys know it. It sounds like most of you have been here before already.
Yes.
And yeah, go
to techtechpotato.shop or shop.techtechpotato. Forget which way around it is, but go there.
Well, now I've paid my taxes. I actually understand how much money I have to hire people, and merchant community may be on that list. So yeah, get more excited for doing things. So cool. If that's all, we'll see you on the next one. Say goodbye, George.
Have a good one, folks.
I was expecting you to say goodbye, George. If you like this content, there are multiple ways to support the channel. You can like and subscribe this video, and many thanks for doing so. There's also Patreon, which gives you access to our Discord. There's a merchandise store and a newsletter, links in the description. For all of you who do contribute, thank you. You are keeping me well fed.